So the process of finding a function from its derivative is called anti-differentiation. If you like, it is the opposite to differentiating. Now, when we do anti-differentiate, we use this notation here. So that elongated S means the integration sign, and the capital F means that it is the antiderivative. But have a look at that C there, and the C becomes really important. So if we're looking at this one down here, the antiderivative of 2x is x squared plus c. Now, why is that the case? Well, if you think about it, if I had y equal to 2x and I was differentiating that, then dy dx would be equal to 2. If I had y equal to 2x plus 7, the derivative of that would also be 2. So we need to put that plus c on the end just in case there is a constant there originally that we have to put back in again. So some important things about integrating. Yes, it is the opposite to deriving. So when we integrate, we are now going to add 1 onto our power and divide by that power. So we'll have a go at a couple in a minute. Some other important things here is that you can take the constant outside when you are integrating, and you can break up two functions in terms of x and integrate them separately, like in this rule here. And the last one here is when you are multiplying, you can multiply them separately as well. Now, when we integrate, we don't have as much power as when we differentiate. We can do a lot more derivatives than what we can antiderivatives. So in this example, we're asked to find the general antiderivative, or another word is the indefinite integral for the following. So 4x cubed. So really what we're doing here is integrating 4x cubed with respect to x. So that's the notation, that's the mathematical notation. So straight away we can take the constant out the front there, and we've got x cubed dx. And what do we know? We have to increase that power by 1 and divide by that power. So it's 4 times x to the power of 4 divided by 4 plus c. All right, and so therefore the 4's cancel out and you're left with x to the power of 4 plus c. With the next one here, we can do it bit by bit. So again, what are we looking for here? We're integrating 2x cubed plus x squared plus 3x plus 4, and that is all, if you like, with respect to x, so dx. What is that looking like? You can take out your constant if you want, but we're going to do it all bit by bit. So 2x to the power of 4 divided by 4 plus x to the power of 3 divided by 3 plus 3x squared divided by 2 plus 4x. Remember, a constant, you add on the x and then don't forget about that, plus c. Let's tidy that up. 2 and 4 cancel down, and so you've got x to the power of 4 on 2 plus x cubed on 3 plus 3x squared on 2 plus 4x plus c. Now you could get a common denominator there for the whole lot, but that is a general antiderivative in that format. Now the next one, we're given f dash of x and we want to find f of x. So that means that we're anti-differentiating. So f of x would be equal to the integral of x squared plus 2x plus 1 dx. So let's integrate that first because we've got another part here, and that becomes x cubed on 3 plus 2x squared on 2 plus x plus c. Now we're given another bit of information there, told that f of 1 is equal to 4. And that really is when x is equal to 1, y is equal to 4. So we're going to use that here because we've got f of x. So f of 1 would be, wherever I've got an x, I'm going to put a 1. So it's 1/3 plus, okay, that cancels. So plus 1 plus 1 plus c is equal to 4. See how now we're going to be able to get our c value. So what do we have there? We have 1 and 1 is 2, 2 and 1/3. Bring it over the other side. So 4 minus 2 and 1/3. And what are we left with? We're left with 1 and 2/3. Or as an improper fraction, it is 5/3. Therefore, we now can write what f of x is equal to. F of x is equal to x cubed on 3 plus x squared plus x plus 5 on 3. So we now have our constant there. Last one, finding y in terms of x, if dy dx is equal to x squared plus 2x and y is equal to... So this question is actually asking exactly the same thing as the one above. It's just written differently. So we're looking for y, and we've got dy dx. So we know that y is equal to the integral of x squared plus 2x dx. And we've got our coordinate, but let's do this first. So y is equal to x cubed on 3 plus 2x squared on 2 plus c. Now, when x is equal to 1, y is equal to 1. That's what we're told there. So let's substitute that in so we can get our c value. And so we get 1 is equal to 1/3 plus 1 plus c. So again, we should be able to manage our c here. Bring 1 over and it cancels. Bring the third over, so we get minus 1/3 is equal to c. Final answer, therefore, y is equal to x cubed on 3 plus the 2's cancel out, so we've just got x squared, and the c is minus 1/3, so it's minus 1/3. And that is y in terms of x.